In the following chapter, I'm going to show you how to turn massing or volume studies into actual BIM models. In the first example, I'm going to do that with direct modeling tools, and in the second one, I'm going to show you how to do that with quick building. So let's get started and open up our first drawing. So let me just open this overall train station model, and as you can see here on the other side I have a block ready, but what we basically want to do is create a similar kind of geometry for this building. So let's see how we can manipulate this block and create a similar building like the other side of the train station. This is an external reference, an XREF, so let me just open up the separate DWG file in Modify, and then you can open XREF. So now you will be directed to the actual DWG file, and then we can start modeling our block. So this is just a regular 3D solid. It's a full massive solid, so let's see what we can do. First things first, let's create or rotate some faces. So make sure that your detection of faces is on, so you can toggle it on here or here. So prioritize selection of faces, and then for example hover over this face right here, and then you can check this command here, sorry, rotate. So then you will see this icon appear of an arrow, and it will indicate or snap to a certain axis where you can rotate this certain surface. So in this case I want the axis to be at the bottom, so you can click on that, and then you see now I can have a rotation of that surface to a certain degree. So this is a very clear preview for that. So in this case, let's do 10 degrees going out. So we can manipulate our block like this. So now you see if I go to the side, it's a bit rotated. Let's do it the same way for our top face and the other side. So hover over this solid face, click on rotate, select a certain axis, and then type in the degree angle that you want to change. And then lastly, maybe the other way around, so just instead of going up I should go down like this. And then lastly I can do this part as well at 15 degrees. So our building should look something like this. Now of course this is just still one massive building, and we want to create some columns underneath to have it a bit more floating and appear a little bit more light. Here I already have 2 polylines created, here and here, setting the boundaries of that. So let me also turn on the boundary detection. So enable boundary detection right here. So if I hover over it, you see this green surface that is defined by the edge of the solid as well as the polyline and the line right here. So I can hover it like this or like this or like this. We want this boundary, so select that, and then go ahead and open up push and pull and push it upwards for about 5,500 millimeters. So now our building should look something like that. If I open up a section, let me turn off the boundary detection first. If I open up the section here, I can hover to see in which direction I want to have this section, and open it for like about 3,000 millimeters. You can see that my solid is massive, so this is full inside, there is no space. So of course for a building, ideally you want to have it hollowed to create some space for that. For this, I'm going to go to the modeling tab, and then here in solid editing you will find a command called shell, and then I'm going to use that to hollow out this massive solid so I can create an outer shell for this building. Click on that, select the 3D solids. If I want to remove certain faces, not really, and then I can enter an offset, so in this case 300. And now you see everything is hollowed out with an offset of 300 millimeters, and then I can enter to exit the command. So like this looks already much better. If I close the section, you see how it looks like from the outside. It doesn't have too many difference in it, but now if I hover over it, it's still one big solid. But of course in BIM the ideal workflow is to have all separate entities, so for each and every wall and every slab, a rooftop and so on, you would like to have it as a separate entity so you can store separate BIM data inside of it as well. So let's do this. You can do this manually, but you can also do this more automatically. In this case, let me just select the solid and go ahead and use BIM split. So it will split segmented solids into separate solids. So if I click on that, you will see now if I hover over it, you will see instead of like one big solid, I have some separate solids in between. So that looks pretty good already. Maybe only for this part I want to have it as a one big solid instead of like two separate things. For that I can use union here to merge them back together. So on the other side as well, I'm just clicking the upper solid and then the lower one and use union to combine both. Of course, because of the splitting and this union, you see that here I have like a weird connection on the other side as well. We can quickly solve that with push-pull. So let me just open up the push-pull setting. So there's a setting called DM push-pull subtract. It should be on, so that means that it will also automatically delete the overlapping solid, so that's good. But if it was off for you on 0, please type in 1 and enter to make sure it automatically subtracts as well. So what it does is if I open up or zoom in and then enable prioritization on selection of faces, can hover over it somewhere here and I can press tab to toggle between the different layers underneath. So toggle until I have this layer, and this is actually the back face of the other wall, and I can use push-pull to push it forward. And if I have the E-snap on, of course, I can, hold on, enable E-snap to endpoint. Okay, so again, using tab, choosing the back face and then pushing it forward like so. So now you see I have one big part and nice connection of the walls. Of course here I still have like one little line. Because of that I can press Ctrl and hover over it so I can select this solid edge and just delete it. So that looks pretty good. Let me also do this for the other side. So just zoom into the connection that I want to change. Hit tab until I select the back face and then push-pull it forward. And then Control select the edge to delete. So like so I have solved my little connection issue right there. Okay. Let me open back up double clicking the section to open it up from the inside. Or what you can also do, let me just delete that for a moment. You can also select this, if I turn off the faces, so I can just select the solids. If I select this front facade right here, I can also choose to, instead of delete, or I can choose to hide it for a moment. So with BIM select and then hide entities, I can just make it disappear for a moment, and later on I can pull it back up. But now I can see how it looks like from the inside. What I want to do here, because here the BIM split automatically splits our slab a little bit too much. So instead of one face, one solid, I have 4. So let me just select the 4 and union it. And then here I want to close off this gap. So if I just select this solid face and connect with nearest, I can clean it up like this. So now I have one big slab. What I also want to do is have a separation between this part and this part. So I would like to have this wall extended to the top of my roof. Here I can do that by, first of all, changing the connection between this slab and this wall right here. So if I select these and go ahead and open up L-Connect, I can use the control key to toggle to the different options. So in this case, I want to have this one, press enter. So I can quickly select the top face of this wall, and then I can choose to connect to nearest as well. So now it will automatically connect to the rooftop. So like this, I can play around with my inner walls of my building a little bit. The last thing that I want to do is add in some more floor slabs inside. So how I can do that is just, let me just zoom in a little bit and select the face of this slab. So I can do this with prioritize selection of faces or hit control, and I'm selecting this face of my slab, and then I can go ahead and BIM copy it. So it will copy this floor slab upwards basically. So I can type in 4000, and then I can also type in repeat, R for repeat, to kind of do the same thing. Sorry, let me do that again. So just select the solid face, type in 4000, repeat, and then you can actually repeat it as much as you want, but in this case it's until here somewhere, so just 2 is fine. So like that you can copy around your elements inside your building, and then here at the top I can select both ends of the slab, and then also use connect with nearest to connect it to the wall. So like this, you don't have to manually model it. This BIM copy also works with boundary detection, so it's not only for faces. If I toggle on boundary detection and I zoom in here, instead of selecting the entire face of this big wall right here, it just takes in account the area between the 2 floor slabs, so the green part right here. And then with that you can also use BIM copy to kind of create sections of walls. So like this you can copy sections of walls in a perpendicular situation. So like this you can create some more interior walls. So this was a little bit of how to quickly model a building from a mass and use direct modeling tools to add in more and more detail in your geometry. So I have showed you how to use direct modeling tools to create a BIM model out of a mass model, but we also have a more specific tool for that called Quick Building, and it's designed to turn massing studies or mass models into a low level of detail BIM model. So you can generate this from space volumes or from building volumes, and this transformation from volume study into building happens in a semi-automatic way, so you can quickly iterate between different volume variants at the beginning of the design stage. So here I have two examples ready to show you what I'm talking about. So this is just my master model. So if I hover over it, you will see I have an X reference here. So let me just open up this X reference in my separate DWG. So this is just a 3D solid, so this is the massive model, so it's not hollowed out or in any case. So if I open up the section, you can see it's full inside, so it doesn't have any spaces or anything like that inside of it. So if I just delete it back, I just have one solid. What I'm going to do now is select the solid and then open up my quad cursor, and then in BIM you will find this icon right here called quick building. So let's do that, and you will see I have some command options that I can do. In this case, it already gives me a configuration. You can also import a certain configuration about the different levels that you want to have, or heights and so on. In this case, I want to have it as 300 millimeters, like this, and the rest should be fine. Selected solid represents a building, that's also good, and then the wall and slab thickness is 250, which is fine. Of course, you can change that. You can also add a floor where you want to have a 2,500 height instead of 3,000. That's perfectly possible. So let me just apply it. And then now, as you can see, another file has been created with the same geometry, but as you can see now, everything is divided up in walls, rooftops, floor slabs, and so on. So if I now open up a section again, maybe something like this, you will see that it's hollowed out, and each and every floor has a different floor slab. Everything is nicely created with a floor height of 3,000 millimeters. So this is what QuickDraw does. It will automatically hollow out and create the spaces, slabs, walls, rooftops, and so on, and give it a classification as well. You can also go ahead and open up the command line, and here for each and every floor it will also give you some feedback about the area, the footprint area, total projection area, surface area, and so on. So total floor area and all that information. So that's a nice thing to have an overview of. So like this, you can try out different volumes and see what each and every volume has as a result to compare. Another example is with a lofted floor. So it does only work with rectangular solids. It also works with lofted or curved solids as well. So if I also open this XREF, I can just use the same command, BIM QuickDraw. Again, it will give a preview, and I can set some settings for that. So let's say instead of 3,000, let's say 4,000. And then I can say, all right. And the rest looks fine. Of like, I can also add a floor. So to say, so like floor 28, I want to have it a double floor as a penthouse, like this, and it should recalculates the rest of the building. So now, if you can see in the preview as well, it will make the top floor higher. Or maybe we can do it the other way around. Have the entrance 8,000 and the rest 4,000. And then maybe the floor slab, instead of 250, make it 350. So I have something like this. It might take a while to load, since it's a more unique geometry with all the curved walls inside, as well as the atrium in the middle. Okay, now we have the final results of our quick draw command. As you can see here, all the levels have a height of 4,000, with the exception of the ground floor, where we indicated that we wanted to have a double floor. So that looks pretty good. We can also open up a section and double check to see. So maybe somewhere 5,500. And as you can see, even though it's curved, everything looks pretty nice. If I hover over some entities, I can have a certain building story, slab, wall, so everything is nicely classified as well. If I open up the command line, you can also see the different floor areas per floor, as well as the total floor area information. So like this, you can quickly check and compare your volume studies with Quick Draw. Of course, after Quick Draw, you can still use direct modeling tools to, for example, edit some parts of the building. So that was it for modeling with masses. I showed you how to do that with standard modeling tools like extrude and push-pull and so on. And then I also showed you how to do this more automatically with quick building. Thank you for watching, and I'll see you in the next module.